In today's video, we're going to take a look at fuel cells, with a focus on how the hydrogen-oxygen fuel cell works, and also at its pros and cons. Now, a fuel cell is a type of electrochemical cell, which means that it converts energy between electrical and chemical forms. More precisely though, they convert the chemical energy of a fuel and oxygen into electrical energy that we can then use to power things. There are a few different types of fuel cells, but the most common is the hydrogen-oxygen fuel cell, which combines hydrogen and oxygen to form water, at the same time as generating lots of electrical energy. The setup of these cells is kind of complicated, so let's run through the structure first, and then we'll see how it works after. In the very center, we have the electrolyte, which is a solution that ions can move through. There are lots of different types of electrolytes, but one of the most common is potassium hydroxide. On either side of this, we have the electrodes, with the negative anode being on the left and the positive cathode on the right. And they're connected by a wire on the top, which allows electrons to flow from the anode around to the cathode. One of the things that students find confusing here is that it's the cathode which is positive and the anode which is negative, because this is actually the opposite way around to electrolysis, where it's the cathode which is negative and the anode which is positive. So just be aware of the difference and try not to get the two confused. In fuel cells, both of the electrodes are made of porous carbon, which means that they have lots of tiny holes, and they also contain a catalyst to speed up the reaction. On the outsides of the electrodes, we have the anode compartment and the cathode compartment, and each one has an inlet at the top. On the left, hydrogen will enter the anode compartment, while on the right, oxygen will enter the cathode compartment. And finally, once the reaction is over, all of the water and heat will then leave via the outlet of the cathode compartment. Now that we know the structure of the fuel cell, we can run through how it actually works step by step. The first thing to happen is that hydrogen comes in from the left and is then oxidized by the anode, which means that each hydrogen atom loses an electron to become a hydrogen ion. The equation for this loss of electrons looks like this, and we'll come back to it in a moment. The electrons, though, then pass around the wire to the cathode, while the hydrogen ions move through the electrolyte to the cathode. This means that the electrons and hydrogen ions can react with the oxygen that comes in from the right, and together they all combine to make water. As you can see though, we're left with a spare oxygen atom, and so we actually need two sets of hydrogen ions and electrons to react with each oxygen molecule. And if we put that into an equation, then this will be the reaction that's happening at the cathode, because each oxygen molecule reacts with 4 hydrogen ions and 4 electrons to form 2 molecules of water. And once that's happened, the water then leaves the fuel cell via the outlet, and the whole process is complete. Now, these two equations that we have here are known as half equations, because they show the loss or gain of electrons. In our case, they show the oxidation of hydrogen and the reduction of oxygen. And if we combine these two equations, we'd get this overall equation, which shows that we've combined oxygen and hydrogen to make water. The electrical energy of this reaction comes from the movement of electrons through the wire at the top. And although we've shown it as a simple lamp, It really could be any electrical device, and effectively it would be powered by the chemical reaction. To make things clear, if you're asked how fuel cells work in exams, the key thing to mention is that as fuel enters the cell, it becomes oxidized. And this sets up a potential difference across the cell. If we break this down, the fuel in this case is the hydrogen. And by oxidized, we just mean that the hydrogen atoms lose electrons. Then the potential difference part just means that there's a difference in charge between the two electrodes. And this is what drives the electrons around the circuit so that we can generate electricity. The last thing we need to look at are the pros and cons of these hydrogen-oxygen fuel cells. Although we could use fuel cells to replace things like power stations, the main idea is to use them to replace the fossil fuel engines and batteries that we use in vehicles, both of which are polluting. The main benefit is that hydrogen-oxygen fuel cells only require hydrogen and oxygen, which are both abundant, and they don't produce any carbon dioxide or other pollutants as waste. Another advantage is that fuel cells are relatively simple devices, which means that they last longer than batteries do, and they're also less polluting to dispose of when we want to throw them away. The downside, though, is that hydrogen is a gas, so it takes up way more space to store than fossil fuels or batteries. It's also explosive when mixed with air, which can make storing it dangerous. The main problem, though, is that to make the hydrogen fuel in the first place requires energy, and that energy often comes from something like fossil fuels.
If you haven't heard yet, you can find all of our videos on our website, cognito.org. You'll also find questions, flashcards, exam-style questions, and past papers. And we track all of your progress so that you always know what to study next. So sign up for free by clicking here, or browse our playlist here on YouTube.